Welcome back to working with rational indices, example 2. In part A, we're dealing with x to the power of negative a half, and we're multiplying that with x squared root x plus 2 root x minus 3 over root x. So the way in which we're going to expand and simplify this is we're going to go this multiply with that, then that, and then finally the one at the far end there. So jumping straight into it, we're going to get x to the negative a half. Now we're going to multiply it with x squared root x plus x to the negative half in parentheses 2 root x like so, and then we'll add a plus in, go x to the power of negative a half multiplied by negative 3 over root x, like so. Now, simplifying that out, we're going to get x to the negative a half. And rather than dealing with all of these in the parentheses, I'm going to bring them out of the parentheses. And I'm also going to express everything as an index. So I'm going to get rid of all of these radical symbols. So it will be x squared, then x to the half, like so, plus the 2 will come out front, coefficient of 2, x to the negative a half, times x to the half, so the radical is now gone there, plus, should put the 3 here, x to the half times x to the negative half, because notice it is a negative root x in the denominator. And one more thing I need to put in there is dealing with the negative inside the parentheses. So I have to put negative 3 like so. Bringing all of these powers together, we get x, the negative a half, plus 2 plus the half, plus 2x, the negative half, plus a half. So that one's looking like it's going to be easy to deal with. Then the 3, x to the negative half, minus a half, also looking nice and easy to deal with. Getting rid of that, these guys cancel and these guys cancel. So this will be x squared plus 2x to the 0 minus 3x to the negative 1, in fact. That's nice and easy. And then writing that out, we're going to get x squared plus 2, and that x to the power of 0 simply becomes 1, so x squared plus 2 minus 3 over x. So this would be our solution right here. Now going onwards, where in part B we're poised with something a little bit different to what we've seen before. So we're going to use the FOIL method, but notice we've got these variables in the power, but even still we'll deal with it the same as we would any other problem. So to open it up, we'll break it up like that, and then like that, and then we'll deal with this unknown after. So we're going to go 3 to the x, 3 to the x, plus 3 to the x times 5, and it's a negative 5, plus 2, 3 to the x, plus 2, negative 5, like so. Going down, we're going to get 3 to the x, and it's going to be x plus x, like that. Then we're going to get plus negative 5 times 3 to the x, plus 2 times 3 to the x, minus 10. Alright, moving onwards, we're going to get 3 to the 2x minus 5 times 3 to the x plus 2 times 3 to the x minus 10. And the first thing now that I'm going to deal with is look at the first term we have in this expression. We've got this guy here, 3 to the power of 2x. Now, we could leave it at this, but a way to simplify this is, rather than having 3 to the power of 2x, we can bring this 2 down into the 3, and it will become 3 squared to the power of x. So we can go 9 to the power of x, and that's a little bit nicer to deal with. Now, the next step is imagine we've got, let's say, let alpha equal 3 to the x. What we'd end up having is 5 alpha plus 2 alpha minus 10. And using our algebraic laws, we could simplify that to simply negative 3 alpha. And then recalling what alpha actually is, we can write it as 9x minus 3 times 3 to the x minus 10, like so. And one more thing we can remember is there's an implied 1 in that 3 there. So the simplest way we can write this is 9x minus 3x plus 1 minus 10. And this could be the solution to or this could be the simplified solution to the problem posed in part B there. So a little bit of tricky things going on there, but nothing we haven't done before and nothing we can't handle with the tools that we have already added to our toolbox. Now going down, we're dealing with this guy here. So how do we deal with this? Well, it's simply going to be, remember the form a plus b all squared can be written as a squared plus 2ab plus b squared. If we follow this rule here, what we can do is simplify this out. So in this case, a is going to be 2x and b is going to be 2 to the negative x. Now jumping straight into it and using our expression or shorthand expression we've got up top in purple, what we can say is that 2 to the power of x plus 2 to the negative x all squared can be written as 2 to the x squared plus 2 times 2 to the x, then 2 to the negative x, like so, and then that will be plus 2 to the negative x all squared. Now simplifying this out, we're going to get 2 to the 2x plus, we'll go 2, and then inside the brackets we're going to collect the like term, so it will be 2 to the x minus x, like so, plus 2 to the power of negative 2x. Nice and easy so far. Now dealing with this middle term in here, we'll go 2 to the 2x, then plus 2, and then it's going to be 2 to the power of 0, like so, plus 2 to the negative 2x. Onwards, 2 to the power of 2x plus 2 to the 0 is simply 1, so it will be 2, then plus 2 to the negative 2x. And now writing it in its simplest form, we're going to find that we get the answer of 4 to the power of x plus 2 1/4 all raised to the power of x, like so. So this would be the solution. So 4 to the power of x plus 2 plus 1/4 all raised to the power of x would be the solution to 2 to the power of x plus 2 to the power of negative x all squared. So we'll leave it here for this video, and then in the next one we'll do example 3, factorize.